And we're back. Welcome back to the right question. Today's key question is going to be, how do we make our code make decisions for us? In order to hit on this, we'll be hitting in on three key topics: comparators, scope, and conditionals. Last time we introduced a new type, bools. Today we're going to expand on that type and understand exactly what it means to be a bool. So let's say we have a bool. A bool is allowed to be either true or false. That means if I declare a variable of type bool, I would be doing the following. I'd be using the type of bool. I could use a name such as is sunny. And I could set the value to be true. Or I could use a bool and say is rainy and set this value to be false. Both of these would be valid declarations. Now, this is very simple, and I'm sure you could go ahead and plug this into your REPLs and play with it yourself. So I'm not going to go too far into it. However, if you were to go ahead and print this out, you would notice that typing in std_cout is sunny would end up outputting the number 1. That's because bools, while they can be written as true or false, can also be written as 1 or 0, where 1 means true, 0 means false. While this seems very simple, the next logical question is going to be, how do I use bools? Well, let's say you have two numbers A and B. There are a couple of things you might want to be able to tell about them. For example, you might want to be able to ask, is A equals B? So to each of these questions, we're going to have a yes or no answer. Let's plug in some numbers, for example, and say that A equals 100 and B equals 10. Does A equal B? The answer here would be false. Is A greater than B? The answer here would be true. Is A not equal
to B? The answer here is true. Is A less than B? The answer here is false. Is A less than or equal to B? The answer here is false. And is A greater than or equal to B? The answer here is true.
Now, because these produce booleans, there's actually a way to do all of these comparisons in code. For each of these, you're going to have relevant syntax that allows you to write the same question in code. So, what is the code equivalent of asking this question? Let's find out. To ask if A equals B, you would be writing the A equals B. For A greater than B, you would write, for A not equals B, you would write A not with the exclamation mark followed by an equal sign, B. And for A less than B, A less than B. Similarly, less than or equal to is going to be A less than or equal to B. And greater than will be A greater than or equal to B. Now, each of these is like an expression. This is not very different than writing something like A plus B. However, instead of a plus, you are using the equals. All of these are what we call operators. The plus sign is an operator, multiply is an operator, divide is an operator, and just like that, the greater than symbol is an operator. The not equals to symbol is an operator, and all of these are operators. Whenever you take two different values, A and B for example, all you're doing between them is just applying some operator and giving back the result. Now, depending on the operator, you would have a different type come out. For example, if you take two ints and add them together, your output is just going to be an int. However, if you apply any of these comparator operators, the equal equals, the greater than, the not equal to, the less than operator, then what you'll be getting is going to be a Boolean output, because the answer to each of these questions, does A equal B or is A not equal to B, is going to be just a true or false. For example, let's say you are going to write int A is equal to 100, followed by int B is equal to 10. Then you might go ahead and say that if I were going to say another int, C is equal to A plus B, that would make complete sense, because when I take two numbers, 110, and I add them together, I'm going to get the number 110 out, and that itself is going to be an integer. So whenever I apply the plus operator on two types, I'm going to get that same type out. Now let's say I had written A equals B. We know from above that equal equals is asking, is A equal to B? That is going to give us the answer of false. So the return type of the output must be of type Boolean. So that means if A equals B is just going to give me an answer out, so I can assign that answer to any variable that I'd like. So I can call that EQ. So now what I've done is I've defined a variable, EQ, which is equal to the return of the operator A equals B. Let's break that down with a memory table so we really understand what's going on. So my first column in my memory table will be a type. Then I have the name. Then I have the value. And I have the size. So the first type of my variable is going to be an int. The name is A. The value is 100. And the size is 4. I have another variable of type int. The name is B. The value is 100. The value is 10. And the size is 4. Now similarly, I have created a new variable on line 3 where the type is an int. The name is C. The value is going to be, go get A from my memory table, go get B from my memory table, and apply the plus or the addition operator. When I apply the addition operator, I'm saying 100 with my plus operator and then 10 gives me 110. So I can go ahead and write down the value of C to be 110 with a size of 4 since it's also an integer. And then on the next line, I have defined a type of bool. Its name is EQ. And because it's a bool, the size is just 1. Now the value is asking me to go get A, go get B, and then apply the equals operator. Now, when I apply the equals operator, I'm simply asking the question, is 100 equal to 10? And the answer here is false. It is not equal to 10. So therefore, the value of EQ must be false. I know this feels a little weird. how can I have equal signs as an operator? Well, that's just confusing. Why would they do that? When you use an equal sign just by itself, you're assigning a value to a variable. However, when you do two equal signs right next to each other, you're doing what's called a comparison, where you're comparing two values right next to each other. Now, I want to warn you ahead of time. When you first start writing code, you are going to make a mistake all the time where you start missing out an equal sign, or maybe your code doesn't do the right thing because you used one equals instead of two. That's okay. All you need to do is read through your code with a little bit more attention to detail and you'll catch the bug. Now, this is a very annoying bug to catch, and that's okay. Does that make sense? I hope it does, and if it doesn't, just remember you will have exercises to go ahead and practice this type of code. Let's move on to the next aspect of asking what exactly is scope. Scope. Up until now, we've added variables into our memory table by adding their type, their name, their value, and then their size. And sometimes, if the value of the variable changed, we went ahead and updated an existing variable's value. For the first time today, we'll be talking about when to remove variables, and that is related to scope, or the lifetime of a variable. Now let's go ahead and jump over to our coding exercise to kind of show you what we mean. So right over here, let me plug in some sample code. Now, by now, all of you should be able to run this code, so I'm just going to go ahead and run it to confirm that the output is what we would expect. And just like we would expect, z is indeed equal to 1,101. Now, the scope of variables is defined by these curly brackets. Up until now, I've merely told you to memorize that this is where your code begins and ends. However, anytime you have these curly brackets, you are entering what is called a new scope. So, in our memory table, we have a type, we have a name, we have a value, we have a size, and secondarily, we have the last one, which is called a scope. Now, what do we do in this new column for the memory table? Every time you enter a new scope, I want you to put a little star on the line for scope. This is to remind yourself that this is where the scope began. So when I first enter the main segment of the code, I'm going to scope it out for line number 3. In fact, I like to put a : 3 here to remind myself where the scope began. Then I'll go on to line 4 as per normal. Line 4 asks me to name my type as an int, and the name is going to be x, the value is 100, and because it's an int, the size is 4. Line 5 asks me to use the variable with the name x, so that we're already accustomed to, so I'll be using x and then move forward. Then line 6 will ask me to make a variable of type int, name it y, put the value of 1001, and its size is also 4 because it's an int. Line 7 will do something very similar to line 5, where it simply uses the existing y variable. Line 8 asks me to make a type int named z, which is going to go ahead and grab my x, grab my y of 100 and 1001, and apply the plus operator over there. And when I add these together, I will get the value 1101. I'm going to go ahead and fill my table with that with 1101. And of course, the size is also 4 because it's an int. And then line 9 tells me to use my z variable and print it out, which is what I got over here, and then go on to the next line. Now, before we would just stop and no longer go with our code, but because main ended. However, now I'm going to tell you the real reason why we do that. On line 10, we hit the opposite curly brackets. Now, every time we hit this curly brackets, this tells us we are done with the existing scope. So what we'll actually do is we are going to cross out everything up until the nearest scope symbol. If we had multiple scope symbols, we would simply go up to the nearest one. We don't cross out all scopes, only the nearest one. So every time you encounter curly braces, you simply go up the line and cross everything out. And then, because our memory table has nothing left, because everything is crossed out, we now know our program is over. Once the topmost scope ends, our program ends. Now, the next question to have is going to be, how do you end up with multiple scopes? It's actually quite simple. All I had to do in this case was add 2 more curly braces around the last 2 lines. Let's go back and work out on our memory tables what this is going to look like. So I'm going to draw it right below so it's very, very clear what the difference in these 2 memory tables is going to be. So we're going to have a scope section, a type section, a name section, a value section, and a size section. So as always, we're going to start on line 3 where the main segment begins. We find that we're entering a scope because of the open curly brackets. So I'm going to put a star symbol with a :3. On the next line, we'll be declaring a variable of type int, name x, value 100, size 4. On the subsequent line, we'll be using that x, but not modifying it, so it's not going to change our memory table. On line 6, we'll be declaring a variable of type int, of name y, of value 1001, and of course the size is 4, because it's an int. And then on line 7, we'll be using that variable y, but not modifying it in any way. And then on line 8, we're going to do what is the first difference in our code. We're going to add a new scope symbol in our code because we've entered a new scope. Now this is on line 8, so I'll denote that with a line 8 symbol. And then on line 9, we declare a variable of type int. We go over and say that its name is z, and because it's an int, the size is 4. And then I start asking myself, to solve for z, I need to find x. So I find x above me, and it does exist. And I'm going to write down the value as 100. Then I need to find z, or find y, and I'll find y over here. And I'll write down 1001. And then I'll put the plus symbol in the middle, like it requests. And that will give me, just like before, 1101. So I'm going to go ahead and fill that out. And then I'm going to go into line 10. And line 10 simply uses the z variable. And then line 11 goes ahead and finishes the scope. So when I finish the scope of this variable, I am going to cross out to the nearest scope symbol. Now once I've done this, I've finished line 11. Now line 12 tells me cross out the next available scope symbol. So I'll go ahead and cross this out. So as you noticed, it's almost exactly the same code, except Z was crossed out this time earlier than X and Y rather than at the same time as X and Y. Does that make sense? In the first example, we are going to simultaneously cross out everything up until the next scope. However, in the second example, because we have two different scopes that we've started, we also have to clear their scopes out one at a time. So it's going to end up having two distinct groups of clearing out scopes, while the first one clears out all the scope all at once. Why is this important? Once again, we're finally entering the realm of more complicated code with this week's exercise. Whenever you do more complicated code, that means you're going to modify the scope of certain variables. Why are we covering all of these together? That's because the very next thing we'll be covering in this video is the concept of conditionals. Conditionals are simply a combination of putting comparators, booleans, and scope all together into a practical use case. Now, at the beginning of this lesson, I asked you all, how do we make our code make decisions for us? A conditional is exactly the way to do that. Booleans give you true or false. Scoping helps you limit the existence of code. And comparators allow you to create booleans from all sorts of different values. Whenever you have to make a decision in real life, you're going to be making a decision off of a couple of things. For example, I might say, if it's sunny outside, I'll go pick up some food. However, if it's raining outside, I'll order delivery. What I've really put here is that I'm not going to go and order food and also order delivery. I will either order food if it's sunny, but if it's not sunny, I will go ahead and order delivery. That is the basic concept of a conditional. Now, this is a concept many of you have used throughout your daily life all of the time. The only thing you need to learn with respect to programming is the syntax in which conditionals make sense. So whenever you write a conditional, you're going to write the word if, followed by a parentheses, and then you're going to give some variable in here, followed by a curly brace, and another curly brace to end it. Now, a couple key things. When you use this variable, you are not creating a new variable. You must use an existing variable. And the way you'll read this is, if variable is true, do whatever exists in this scope of code. However, if it's not true, simply skip this block of code and just move on to the next line after the if condition. Let's go ahead and go back to our REPL and update our code so we can leverage the concept of conditionals. For example, I might create a bool is x smaller, which is equal to x is less than y. So x is smaller will be true if x is less than y. Similarly, I could have another one that's is y smaller, which is equal to y is less than x. And then when I were to, I could print out if is x smaller, std cout, is y smaller and y is smaller. Now, before I go ahead and explain this code, I just want to go ahead and run it so you can kind of see the output. When I run it, I get 3 phrases coming out instead of 4 that I actually am saying to print out here. That's because I have scoped out all of my expressions. What is this code exactly doing? Let's explore this by writing a memory table. Let's go ahead and try this out with our memory table. So, as always, we're going to have our memory table with scope. We're going to start off on line 3, and we'll create a new scope. Line 4 is going to tell us to make a variable of type int named x with a value of 10 or with a value of 100, size being 4. Line 5 asks us to use that value but does not modify a memory table in any way. Line 6 asks us to create a variable of type int named y with a value of 1001, and the size is 4 as well because it's an int. Line 7 asks us to simply use that variable y and print out its value, which is going to print out 1001. Line 8 does nothing. Line 9 asks us to make a variable of type bool. Name it x is, name it is x smaller. And then use the value from x, which is 100, and then use the value from y, which is 1001. Do the less than comparison, which gives me a true as an output, and set the true value to be the value of my variable. And of course, because it's a bool, the size is 1. The following line, line 10, asks me to do something very similar. It says, make a new variable of type bool, name it is y smaller, and then get the value of y, which is 1001, get the value of x, which is 100, and then do the less than comparison between these two numbers, which will also give me a false value. And of course, it asks me to store false as the value of the is y smaller variable. And because its type is bool, we are going to set the size to 1. And then on line 12, we ask ourselves, are we adding a new variable? We haven't given a type specifier, so there's no way we can be adding a new variable. We're not adding a new variable, but we are using a variable. We're using the is x smaller variable. So I'm going to go ahead and highlight this variable for us. And what it's asking is, if is x smaller is true, and the answer is x smaller is true. So if it is true, then go ahead and proceed to do my code. So when we execute its code, we are going to do a new scope symbol, where this is beginning at line 12. On line 13, it asks us to print out the statement, is x smaller? So we are going to print out x is smaller due to line 13. And then line 14 asks me to cross out to end scope. So I'm going to go ahead and end this scope. And now, because I've ended scope, I am done with this if condition. So I'm going to go on to line 15. Now, is line 15 creating any variables? The answer is no. Is line 15 using a variable? The answer is yes, it is using a variable. It's using the is y small, and it's asking if is y smaller is true, and is y smaller is actually false. So because it's false, we don't even care about where this code is or what happens in this code. We're simply going to go to the end of scope function and just go to the line right after that. So we're going to go to line 18. Now this only happened because is y smaller is false, and this if condition tells us that this following scope of code is only going to be executed if and only if is y smaller is true. If is y smaller is false, we're simply going to skip over it all the way down to the following line after this scope segment. And then line 18 tells us, please go ahead and end scope. So let's go ahead and end our scope. And now, because our memory table is empty, we know that our code must be over. And as expected, this ended up printing out the 3 lines of x is smaller, y is 1001, and x is 100, caused by these lines, respectively. Again, this code seems really simple, but what happens if I had done something slightly more mischievous? If I had asked the user to enter a number, let's say the number 100,000, now I would be getting the output y is smaller. So I magically made the same code make a decision on what I was doing by using the conditional concept. This is, again, one of the most fundamental basics of programming. As we continue onwards, we are going to dive deeper and deeper into these fundamental concepts. Conditionals and operators and booleans are just the beginning of complicated expressions that you can do. That's it, everyone. We went ahead and just covered some of the most foundational aspects of programming. We learned about booleans, we learned about conditionals, and we learned about scope. And to include that in our section, we ended up adding a new column into our memory tables to remind us when we have entered scope and when we haven't. However, all of this may start feeling disjointed and you may not know why we're having to keep track of size and scope. Be aware, all of this is slowly going to be put together into more and more complicated concepts. Just take it nice and slow. The magic of C++ is that every single rule that we're going to be adding is just very simple and easy to understand on its own. There are not a lot of complicated aspects there. However, the complications happen when you try and put many of the rules together. So if a lot of this is feeling easy for you right now, that's fantastic. We'll be getting to the more challenging aspects of putting rules together. And if it's not feeling easy for you, that's okay too. Go on over to the assignments page and submit a request for the next live session, and we'll go ahead and address those concerns in the Q&A or in just a quick written post. Now, once again, we've left some assignments for you this time. You are going to be building on your calculator from last time and making it also account for any operator the user wants to do. Just remember, all we have to do is go on forward line by line and keep on asking the right question. If we keep doing that, there's nothing that's going to get in our way of learning how to code. Looking forward to seeing you all again next time. Goodbye.